So today we will be discussing about one interesting topic, loop engineering. Recently, it is mainly discussed among more technical personnel as well as other uh, individuals who interested in this AI development. So we will discuss about what is loop engineering and how it differ from prompt engineering and how we can use loop engineering our day-to-day tasks likewise topics. So let's start. Mm, so as you all know, recently the CEO of the Anthropic has said in publicly that he usually uh, do not prompt in Claude anymore. What he use mostly is the loops. So he create the loops and handed over the task to the loops, and the rest will be handled by the loops. So not only him, there are several individuals said the importance of the loops when comparing with the prompt. So what we have to understand it is whether this loop anatomy is introduced to the society as a marketing gimmick, or is there any actual value of these loops? So we have to analyze whether these AI companies like Anthropic, OpenAI are pushing to loops to uh, pushing users to consume more tokens will ultimately result in increasing the profits of those AI companies. So let's see. So we have to compare how these loops are differ from the manual loops. Manual loops means, so as we already using the AI agents. So what we does is assume that we want to generate a picture. So what we do is we create a prompt. We prompt and we give that prompt to the LLM. So basically, LLM does the creation of the image. So based on the output of that image, we make a judgment, and whether based on the decision whether if it is a good one, if we are satisfied with that the image generated by the LLM, we take this as the final output. And if we do not like the output that generated by the LLM, we again re-prompting to the LLM to get the next output. So likewise, we go for manual iterations when we are interacting with the LLMs in our day-to-day life. So let's see how this agent loop will replace in the manual loop. In the manual loop, the decisions, the judgments, and reprompting is done by the human. So basically, yes. So in agent loops, that AI agent is replacing that human part. So instead of taking the judgments and reprompting done by the humans, the AI agent will take that responsibility and replace the human. So when it comes to manual looping, the main bottleneck is us, which means that every time the LLM is waiting for us to make the judgments and reprompting. But when it comes to agent loop, that issue is not there, because always there is an AI agent to make the judgment based upon the output generated by the LLM. But that agentic loop introduces new problem, which is how the agent decide whether the final output is okay. Final output will be satisfied by the human. So that agentic loop has a new problem. It has to decide whether where it can stop generating reprompting with the LLM. So to understand this loop engineering, we have to compare it with the prompt engineering, which is more familiar to us. So in prompt engineering, the human, we are the one who judge the output of the LLM. But when it comes to loop engineering, AI agent is the one that make the judgment, and also it can be the same AI agent which uh, uh, communicate with the LLM, which make the judgment, or it can be a separate check. And the iteration model, it is manual. So it basically human is re-enters the prompt based upon the output. But in loop engineering, the cycle is automated with the AI agents. In prompt engineering, human, we are the bottleneck. Every time LLM is wait for our input, but that is automated in loop engineering. But it has its new bottleneck, which is the stopping condition. So in prompt engineering, the success criteria will be whether it is whether the output is satisfied by the human, which whether it will be looks good, then it will be considered as the success criteria in prompt engineering. But when it comes to loop engineering, uh, the success criteria always will be measurable with quantifiable measures, which means the end results, the end goal always should be quantifiable. The prompt engineering always suited for non-scope tasks. But when it comes to loop engineering, as its name suggests, it is best for repetitive tasks where we do not know the number of steps to reach the final output. And in prompt engineering, the speed is slow because basically, as human, the LLM is wait for us to give the make the judgments and reprompt till get the out. But compared with prompt engineering, loop engineering is faster because an AI agent is always and waiting and ready to make the judgments and reprompt. Main risk in prompt engineering is uh, the bottleneck, which means you. But in the loop engineering, the main risk is running out of the tokens, which means if we haven't defined the clear stop criteria, the loop may run endlessly. That is the main risk. And core tools, which means that when we are using prompt engineering, the core tools will be the chat interface. But in loop engineering, for an example, if we get Cloud Code, there are separate tools like /goal/loop for loop engineering. So let's understand how the agentic loop will be work. So in agentic loop, there are main three parts: reason, act, and observe. So to understand the agentic loop, we have to understand these three things. First one is the reason. Reason means reasoning, which means deciding the next move. And what happened to the given goal so far. So based upon the goal that is defined previously, we have to compare it with the latest changes that we have made and make the reasons for the next iteration. The act. Second part is act. Act means the executable actions, which means edit a code, generate an image, call a tool, likewise. And observe means the evaluations part, which means it will be done by a separate checker, agentic checker. So it check the output against the goal. It always iterate and check the output generated by the LLM with the goal defined by us humans. So if the goal is satisfied, then it will be considered as done and the loop will be break. So we have to define uh, a good goal to these loops. If not, if we haven't if we do not give a clear goal to the loop, it will be disastrous. So for an example, if we get if we give an instruction to the agent like defining a goal like until passing the all the unit tests, it will be a quantifiable measured goal which is good. But when it comes to instruction like make this image beautiful, then the agent will not find a easy way to measure the beautiful. So it will be a bad loop. So this diagram illustrates the difference between the manual and agentic loops. When it comes to manual workflows, the quality quality of the content will be uh, not much exponentially growth with the number of attempts, which means uh, it may not given the expected results until we attempt to the sixth attempt. But when it comes to agentic workflows, the it has much more exponential quality growth over the attempts, which means with lesser attempts, it can make a quality content. So there are several tools introduced by different AI companies to introduce this loop engineering. For an example, if we get Claude has tools like Goal, Loop to work with loop engineering. So let's see how we can set up these goals and work with these agentic loops step by step. The first one is set up the clear goals. For an example, until passing the all the unit test or stop after 20 iterations. In here, the condition that is defined by the user is uh, passing all the test or stopping after the 20 turns. Then Claude works it up, which means that agent hand over the task to the LLM and faster model evaluate. So in this case, the same agentic model, the same agent can be used as the checker, or as a best practice, it is always encouraged to use a separate model, separate agent to work as the checker. So this loop will iterate till the certain condition is met. So it is considered as success, and the goal will be cleared if the clearly defined goal is satisfied. And let's see an example. So for an example, this is how a goal and a loop will be written in the Claude code. So I will not going to repeat this text for you. You can see. So in the first one, it has clearly defined a stopping criteria, which means that stop when all the t. When we define a loop, it also has defined a clear stopping criteria. If not, the tokens will be run out. So in that loop, the stopping criteria will be running every 30 minutes. So there are currently there are three main ways to execute an agentic loop, which means a solo loop, make a checker, and manage helper. Solo loop means in there we are using one agent, and that same agent will be used as the maker and the checker, which means it does all the three aspects, which means reasons, acts, verifies, and repeats process, all done by single agent. And the next one is maker checker, which means uh, a maker agent will take the responsibility of reasons and acting, which means the build, and a checker agent will be take the responsibility of evaluate. It is considered widely considered as the best loop engineering method currently exists. And the third one is manage helper, which means it is run as an agent orchestrations, which means a manager is there, and there are several agents who work under that manager, and that when the manager give the reasons and act, the the level which resides below that manager in the hierarchy will work as the evaluators. So let's see how does a good loop look like. So first one is dog sweep, which is a popular loop pattern which stands for update the stale dogs to match the code. Stop when dogs match. The PR pull request is open. Likewise, there are good loops. Standard good loops are there. So basically, we can use them more, give our own loops, which is good as like this is. So let's see a general example of agentic loop. For an example, I have taken and generating an image. So a make a checker loop is used in this example. And for this example, we have get creating a logo. So as you can see, the text as the goal, like generator Fox mascot logo, flat vector style, transparent background, no text, regenerate until the checker confirms all the criteria pass or stop after 8 attempts. So in this text, which we also can tell like a prompt. So it clearly separated the three aspects of agentic loop. So first one is the reason. So reason is done by the maker agent. So what is happening in there is it planned the next prompt, like styling the background and applying the logo colors like this. And the maker is also act as the act, which means it agent will communicate with the image model LLM and generate the image till the times, and the observe, which is done by the checker agent. So it will evaluate the image generated by the LLM until the condition is met. So if you carefully analyze this text, you can identify what is the stopping criteria. There are two stopping criteria. The first one is until all the criteria are passed, or the second one is stop after 8 attempts, which is basically useful for stop consuming more tokens than expected. So likewise, we have to define a clear goal in every agentic loop. So in this visual diagrams also explains that same example. So make a communicate with the LLM and it executes the reasoning, generate attempts to n attempts n, and it will be evaluated using the checker. And the checker will decide whether the condition is satisfied or not. If the condition is satisfied, that all the criteria are met, it will be considered as done. If not, it will again re-prompting to the maker to make a new image. So should I use a loop, which stand for whether we have to use loops always? So are there any specific occasions we have to use loops? So as every AI tools, loop is not considered as a good tool for every task. So we have to decide whether to use a loop or not based on the evaluation criteria. For an example, if the task is repeated and it will be taken many unknown steps, we have to use a loop. And also special point is there, which is whether the agent can check against the goal, whether the goal is quantifiable. So if these all three questions are answered and all the answers to those questions are yes, we have to use a loop. And if any of these questions are answered as no, we do not have to use an agentic loop. Now we have to analyze what are the pros and cons of loop engineering. The first, let's first consider about the advantages. So agentic loops are removing the human bottleneck by replacing the human with AI agents. And it is reaching the end result faster than the prompt. Because as the graph shows, the quality of the content is exponentially increased with the number of attempts. And scales to repetitive tasks with an unknown number of steps. And loops are clearly loops are better to apply. Whether the number of steps to complete to go for the ultimate end result is unknown, it can be used. And it is also, as human is replaced by the agent, the human time will be saved. And when it comes to cons, as of the first slide mentioned, it has also its own bottleneck, which means how it is, how the agent decide whether the stop condition is stop condition the success criteria have met. And also, as we are uh, handing over this task to agent, it is advisable to users to use a separate isolated environment for the agents. And the quality of the output always defined on the goal that we have defined. And also the loop engineering is depend on the number of tokens. And it's upfront design overhead, which means that in prompt engineering, we do not have to decide how the end results will be look like. So with each iteration, we can make changes and do modifications until the satisfactory levels are met. But when it comes to agentic loops, we have to design the upfront. We have to define the clear stop condition, goals, and what are the tools and how the memory management will be done before the loop start. Upfront designing is there. And also in these 10 points, I have defined the guardrails and best practices to use agentic loops. The first one is checkable call. If you are using loops, we have to always give a quantifiable, measurable end result, stopping condition. And also, if the goal is not going to be met with 7 to 8 iterations, we also have to define a hard stop. Whether the end condition, the goal is not met, we have to put an end hard stop to limit the token consumption and isolate it. So as we are handing over these tasks to the AI agents, we have to isolate the environment. Otherwise, the AI agent have the ability to take over the important artifacts of your computer. And mind the cost. As this is run as iterations, we do not know the number of iterations, or if we haven't mentioned the number of iterations that is run with this loop, it will be hugely cost. It will be costly as it uses more tokens to get the end results. And also always use good tools. Whether as we are designing upfront, we have to define what are the tools that is going to be used with this agentic loop and the memory. And we have to consider about the memory management. If the loop is continuously, if assume that the loop will be run 50 times, there will be more memory. So we should have a way to summarize the context to uh, get more reliable out, and always use a separate checker rather than making the maker as the checker. It is always a good practice to make a separate checker which validates the output made by a separate maker. Plan first and then loop. So it is very much important. We have to define the goal, stop writing hard stops, what are the tools used first before running the loop, and log everything the loop does. So we have to keep a version history of the what of the things that is happened with the loop, and always know your kill switch, which means you should always know how the agent can be stopped if it is go beyond the defined goal, or if it is not likely to be stopped with the given specified criteria. So these are some of the best practices and guardrails to be used in the loop engineering. So I hope you have got a somewhat knowledge about what is loop engineering. So loop engineering is a evolving process. So it is basically replacing the manual manual AI workflow done by the human with using the AI agents. So by deciding whether to use a loop or not, by using right tools, by designing upfront, these agent loops can be used to improve the efficiency in a huge way. So that's all for this session. So I hope you got an understanding about loop engineering. So thank you.